Let's analyze the given graph of the circle and then draw the standard form of its equation. Hello, do not forget that in order for us to come up with a standard form for the equation of a circle, we need two things. Number one, the center of the circle, and number two, which is the radius. Looking at the two circles here, let's focus first on this gold colored circle. We have here its center at this point. Looking at the Cartesian plane and thinking that each grid is one, the center is located as 1, 2, 3, 4, 5. Its center is at -5, and then 1, 2, 3, 4, 5, positive 5. So we are now sure with its center. But we need to come up with the radius first. Looking at the given figure, this circle is actually tangent to both x and y axes. When you say tangent, it only touches the x-axis at this point here, as well as it only also touches y-axis at this point here. Even without other measurements given here, we can just simply look at the trend for the movement of the center from the axis. Here, we have here 1, 2, 3, 4, 5. So the length of this radius is 5. If we're going to go down, 1, 2, 3, 4, 5. It's also 5 here. This means that the radius is given to be 5. Now that we have its center and radius, let's try to draw the standard form. Take note that the standard form is written as x minus h, the square of x minus h, plus the square of y minus k, and equal to r squared. By substituting, we have here x minus, not forget that this is h and this is k. So it's a negative value for h. So make sure to enclose them in a parenthesis so that we could consider the difference of signs later. Plus, you have y minus positive 5, the square of it, is equal to r squared, which is 5 squared. And then simplify this and that. You will have here x plus 5, the square of it, plus the square of y minus 5 is equal to 5 squared. Or if you would like to simplify this area here, you may have x plus 5, the square of x plus 5 rather, plus the square of y minus 5 is equal to 25. Both of these forms are acceptable and are correct for the gold colored circle here. Next is for the green colored circle here. We have noticed that its center, again, as what we need, is located at this point here. So for the movement from the x-axis, considering that each grid is 1, you have 1, 2, 3, 4, 5. So its center, let's use a green color. So the center is at 5, and then 1, 2, 5, and then 2. However, unlike in the first circle, which is tangent to both axes, this circle here is not anymore tangent to both. So we cannot use the concept of tangency, moving horizontal and vertical movement for the center to get the radius. But what we could do here is to use this other given point. This point here has coordinates 0, 4, 1, 2, 3, 4, 5, 6, and 0 for the x-axis. This is the coordinate of this point. Why do we need that? Even if we don't have the situation that could predict the value for the radius, when we have points, 2 points, we have the center and a point on the circle, we could come up with the radius. Take note that the definition of a radius is that it is a line or a line segment drawn from the center of the circle to the point to any point, rather, to any point on the circle. And then that said line segment, its distance is the value for the radius. In short, we need to get the distance between these 2 points to determine the value for r. And the distance formula is written as the square root of the movement of x. You will have x sub 1 minus x sub 2 rather, x sub 1, take the square of it, plus y sub 2 minus y sub 1, and take the square of it. You could always interchange first y and x because addition is commutative. And you could also interchange here x sub 1 and x sub 2. Never mind the value for a negative since it still be squared. But make sure that if it's x sub 2 here, it's also y sub 2 in this area. Do not write here x sub 2 minus x sub 1 in this area. You're going to interchange the values. It might be wrong later. So let's continue. Let's take this as our point 2 and this is our point 1, or either way around. And then you will have your x would be 5, x sub 2 rather. So x sub 2 is 6 minus 5. You take the square of it, plus y sub 2 is 0 minus 2. Take the square of it. So you have square root of, that's 1 squared plus negative 2 squared, which will result to the square root of 1 plus 4 will yield square root of 5. This is the distance between the 2 points. Again, square root of 5 is the distance between the center, this center here, which is at 5, 2, and then this point on the circle, which is 6, 0. Literally, if we're going to combine them, this distance is also the same as the value for the radius. So this square root of 5 is also your radius. We need this process to get the value for r and to be paired with this center to get our equation in standard form. Standard form, we have center, radius. So let's proceed with its standard form. It will look like, let's use a green color here. You have x minus 5. This is what we're going to use, not this, because this is what the center is. Take the square of it. Then y minus 2 squared is equal to r. Your r is square root of 5 and then squared. Take note, r is square root of 5. But the standard form is r squared. So this is already acceptable. Or the other way around is when you're going to take the value for the left-hand side. You have y minus 2 squared is equal to the square root of 5 is just simply 5. So these two are just the same out from simplifying this value here. So this video is also for standard form. Do not forget that we need the center rather and the value for the radius. Goodbye.